Hello students, today in our 11th physics, let us start the lesson Laws of Motion, and this is going to be the session 3, and today we are going to see the important topics. They are concurrent forces and LAMI'S theorem, law of conservation of total linear momentum with some examples, then impulse with some important illustrations. Let's see. First of all, let us see the concurrent forces. What do you mean by concurrent forces? A collection of force is said to be concurrent if the lines of forces act at a common point, or if a system of three concurrent and coplanar forces is in equilibrium, then they are called concurrent forces. And LAMI'S theorem states that the magnitude of each force of a system is proportional to sine of the angle between the other two forces. Let me show what's that. See, in this picture, the force F1 and the force F2, then the force F3, all are proportional to the sine angle of the other two forces. F1 is proportional to F2 and F3. F2 is proportional to the sine angle of F3 and F1. Likewise, see, all the F1, F3 and F2 have their own angle values like alpha, beta and gamma. So, the constant of proportionality is the same for all the three forces. Now, let's consider the three coplanar and concurrent forces F1, F2 and F3, and which act at a common point, which is O here. So, F1 modulus vector is directly proportional to sine alpha, and F2 modulus vector is directly proportional to sine beta, and F3 modulus vector of is directly proportional to sine gamma. Therefore, F1 modulus vector is divided by sine alpha, which is equal to F2 vector modulus is equal to sine beta, which is equal to F3 vector modulus. Now, law of conservation of total linear momentum. When two particles, here let us consider the particle as P1 and P2, interact with each other, they exert equal and opposite forces on each other. So, according to Newton's third law, F vector 2 1 is equal to minus F vector 1 2. Let's take this as equation number 1. Now, in terms of momentum of particle, the force on each particle, that means using the Newton's second law, we can write it as F vector 1 2 is equal to dp1 vector by dt, and F vector 2 1 is equal to dp2 vector divided by dt. Let's take this as equation number 2. Here, P1 is the momentum of the particle 1 and P2 is the momentum of the particle 2. While substituting the equation 1 in equation 2, we get P1 plus P2, which is the total linear momentum of the two particles. Then P vector total is equal to P1 plus P2. It's also called as total linear momentum of the particle. If there are no external forces acting on the system, then the total linear momentum of the system P total is always a constant vector. Now, the forces F12 vector and F21 vector are called internal forces of the system because they act only between the two particles. There is no external force acting on the particle from the outside. In such a case, the total linear momentum of the system is a constant vector and it is conserved. Let's see some examples for this total linear momentum. First one, let's have a consider firing of a gun. Here the system is gun plus the bullet. Initially the gun and the bullet are at rest, hence the total linear momentum of the system is 0 because there is no fire inside the bullet to jump out. Let P1 be the momentum of the bullet and P2 be the momentum of the gun before firing. Initially both are at rest. Now the total momentum before firing of the gun is 0. So P1 is equal to 0 and P2 is equal to 0. According to the law of conservation of linear momentum, the total linear momentum has to be 0 after the firing also. So when the gun is fired, a force is exerted by the gun on the bullet in forward direction. Now the momentum of the bullet changes from P1 to P2. To conserve all the total linear momentum of the system, the momentum of the gun must also change from P1 to P2. See, you can say it's initially at rest, then this gun began to explode. There is a momentum in between this finger and this reaction. Actually, the gun recoil force of the gun. This is a recoil force of the gun and this is the accelerating force on the bullet. Now, due to the conservation of linear momentum, P1 plus P2 is equal to 0, which implies that P1 is equal to minus P2. The momentum of the gun is exactly equal but in the opposite direction of the momentum of the bullet. This is the reason after firing the gun suddenly moves backward with the momentum P2 vector. It is called recoil momentum. This is an example of conservation of total linear momentum. Now let's see what do you mean by impulse. If a very large forces acts on an object for a very short duration, then the force is called impulsive force or impulse. If a force F acts on the object in very short interval of time, which is del t, from Newton's second law in magnitude form, it is denoted as F dt is equal to dp. Integrating over time from an initial time t1 to the final time tf, we get integration f to t dp is equal to integration ti to tf f into dt. Therefore, let us put the right hand side as pf minus pi is equal to integration ti to tf f into dt. Pf minus Pi is equal to del P, which is called change in momentum of the object during the time interval Tf minus T1, which is equal to del T. The integral Tf by Ti f dt is equal to J, and which is called impulse momentum equation, or it is equal to the change in momentum of the object. If the force is constant over the time interval, then the integral of T f to ft f dot dt is equal to, let us take f as common out from the integral value. So f into integral T I to Tf dt is equal to f Tf minus T, which is equal to f into del T. F del T is equal to del P, because the above equation is called the impulse momentum equation. The impulse is a vector quantity and its magnitude is ns. For a constant force, the impulse is denoted as J is equal to F del T, and it is also equal to change in momentum P of the object cover the time interval T. Let's have some illustrations and some basic questions about this impulse. First question is, when a cricket player catches the ball, he pulls his hand gradually in the direction of the ball's motion. Why? This question arises even from the cricketers and to the normal people who are residing with us. Let me answer this question. If he stops his hand soon after catching the ball comes to rest very quickly. It means that momentum of the ball is brought to rest very quickly. So the average force acting on the body will be very large. Due to this large average force, the hands will not get hurt. To avoid getting hurt, the player brings the ball to rest slowly. Second question, what happens when a car meets with an accident without airbag? I know we all are aware of accidents nowadays, and even these car bags will support the driver without any hurt in the chest and head. See the picture, and now let's move to the theory. When a car meets with an accident, its momentum reduces drastically in a very short time. So this is very dangerous for the passengers inside the car, since they will experience a large force. To prevent this fatal shock, cars are designed with airbags in such a way that when the car meets with an accident, the momentum of the passengers will reduce slowly so that the average force acting on the system will be smaller. Third question, what is the use of shock absorbers in two-wheelers? I think you all know what is the use of shock absorbers in your day-to-day life. Now let's explain. A shock absorber in two-wheelers plays the same role as airbags in the car. When there is a bump on the road, a sudden force is exerted to the vehicle. The shock absorber prolongs the period of transfer of force onto the body of the rider. Now vehicles without shock absorbers will harm the body due to this reason. You can see that shock absorber. Here it's a transverse link. Fourth question. Which is dangerous, jumping on a sand, concrete, cement floor, or jumping on the sand? Jumping on a concrete cement floor is more dangerous than jumping on the sand. Sand brings the body to rest slowly than the concrete floor, so that the average force experienced by the body will be lesser. If an egg is thrown, can you catch the egg safely without breaking it? If you tell yes, then how? When trying to catch an egg with the furthest distance, the important things to keep in mind are weight of the egg, the distance you are throwing it, and how you catch the egg. The catching of egg can be particularly difficult because the egg is very brittle and fragile. In order to reduce the momentum, you must drag the legs by its sides so that it does not splatter on your hand. Last paragraph. The egg's impulse, which is its average force over a period of time, must be reduced in order to ensure a safety handling for the egg. By grabbing the egg by the sides, you are reducing its momentum and impulse to later make the egg fall into your palm. Thank you, students. Study well. It's very important. Thank you for your patience.